Now we have de Moivre's theorem. That's how you say it, de Moivre's. You know, I'm bad at spelling, pronouncing French things, so by the time I probably get to this in class, I'll probably have forgotten how to pronounce it because I just had to look up on Google how to pronounce it right. But it's de Moivre's theorem. And essentially what it says is if I want to take a complex number and raise it to a power, then in polar form, as long as it's in polar form, all I gotta do is raise the modulus to whatever exponent I want to raise it to, and I'm going to do the cosine and sine of an angle that's produced from me taking the original angle that was there and multiplying it to the new power of my complex number. This particular thing works really well for situations where I have really large exponents. If I'm just asked to do a squaring, like in part A, I'm going to probably do the foiling as I normally would, and that's what I'm going to show here. You don't have to use this theorem to get to this point. It's a lot easier to do this. And, if I wanted to, just to make my life a little easier, I could say that this is the same thing. One way of handling this would be to look at this thing and say, well, that's 3 plus 3i squared raised to the 10th. And then, since I know that 3 plus 3i squared is 18i, that, so I'd have 18 to the 10th power, which is a pretty big number. You're going to need scientific notation. I to the 10th. Well, 10 divided by 4 is 2, leaving me with 2 left over, so that's going to be equal to I squared, which is negative 1. So I'm going to have a negative 18 to the 10th power. So I can look at it that way. Or what I could do is make it a point to put this into polar form first. So 3 plus 3i. So the only way I could possibly handle this is look at, okay, well, I could take 3 plus 3i and turn it into polar form. So if I put it into polar form, showing the steps I'm showing here, I would end up with 3 times the square root of 2 times the cosine of pi over 4 plus I times the sine of pi over 4. Now I can apply this theorem, which means I'm just going to take 3 times the square root of 2, raise it to the 20th power, and I'm going to take each one of those angles, the original angles, pi over 4, and multiply that by 20. So what I end up with is, doing some simplification, 3 to the 20th power, the square root of 2 to the 20th power is the same thing as 2 to the 10th power. I end up with cosine of 5 pi plus I times the sine of 5 pi. Which means that I end up with 9 to the 10th power, because that's what 3 to the 20th is. I can rearrange that, times 2 to the 10th power, times negative 1, which gives me a negative 18 to the 10th power, which is kind of the answer I produced before. So there's 2 different ways to go about doing it, but the first way I did it was based off of me of already having completed beforehand the 3 plus 3i squared. If I don't have that, then I kind of lose that ability to do that, so going to this route makes it a heck of a lot simpler, because I'm pretty sure you don't want to sit there, take 3 plus 3i, multiply it to itself, FOIL it out, get rid of make sure it's put back into complex number form, do it a 3rd time, and then repeat the process, and then do it a 4th time, and a 5th time, and a 6th time, all the way up to the 20th power. That would take forever. Whereas this is a really, nifty shortcut that de Moivre came up with.